Hi guys, it's Miss B. So today we're gonna go through solving exponential equations using logarithms. What we have seen before is just solving simple exponential equation. For example, we had 2 to the power of x is equal to 8. So when we had this equation, we have realized that 8 can be written the same as 2 to the power of 3, so having the same base on both sides, which is 2. When you do have the same base on both sides, all we have to do is just equate indices. In this case, we're just going to say x is equal to 3. So simple, easy. Now let's do one more similar to this one. So it's 2, I'm just going to go with 2 times 3 to the power of x take away 2 is equal to 162. Please notice that here first you need to get rid of number 2, that's in this number 2, that's in front of 3. So by dividing both sides by 2. So we will be left with 3 to the power of x take away 2 equal to 81. Now the next step would be to look if 81 can be written as a base of 3. So, and we have realized that 81 is the same as 3 to the power of 4. Now I'm just going to copy this side here. So we do have the same base, so which is 3. So all we have to do now is to equate indices. In this case is x. It's x take away 2 equal to 4, and solving simple equation, moving negative 2 to the other side, and you can do actually to get rid of negative 2 you can do plus 2 on both sides. So negative 2 plus 2 is 0, so we left with only x. So x is equal to 6. So this one is solved as well. Now let's move to the next one, the one that actually can't give us a beautiful easy answer, where we do have to apply exponential, or we actually have to apply logarithms on both sides. Okay, let's have a look at this one. 2 to the power of x is equal to 5. Now looking at both sides, we do have on left hand side 2 as a base to the power of x, and on the right hand side we do have 5. So 5 can't be converted into 2, so we can't have base of 2. So what we're going to do, we're going to apply log function, or ln, to both sides. So ln of 2x is equal to 5. Now if you do remember the rule, okay, let's go now with this one, 2. Okay, let's start 2. Okay, let's start with 2x is equal to 5. So we can see that we don't have a nice base on both sides. So what we're going to do, we're going to apply ln to both sides. So ln to both sides. So I'm just going to erase that one. Yeah. And write 5 there. So ln on both sides. So, and if you do remember one of the rules that you have seen before, m ln of b is the same as ln b to the power of m. Now we can apply this rule here in the first part, and we can say, okay, this x actually can be moved in front of ln2 and equal ln5. Now the same as solving any equation, so we're trying to get rid of everything that's next to x, because by solving we're trying to find what is the value of x. So to get rid of everything that's next to x, in this case that's ln of 2, and the way to do that is dividing by ln of 2. When we said get rid of it, it pretty much looks like we need only one x. So in order to get that, ln2 needs to be divided by itself in order to get 1. So we do the same on the other side. So therefore, x is equal to ln 5 over ln of 2. Please note ln 5, ln 2 is not the same as ln 5 over 2. If you want, you can even try that using the graphs or using the calculator, graphs calculator, and see that you're going to have different answer. Okay, let's do one more. So let's go with 6 times 1.2 everything to the power of x, and it's equal to 36. Now, again, the first thing to do is get rid of, anything that you can get rid of. So, eliminating. So the first thing we're going to do is divide by 6, both sides. So 6 divided by 6 is 1, which is beautiful. We're going to be left only with 1.2 to the power of x, and it's equal to 6. Now, still, we can't have the same base. So what we're going to do, we're going to apply ln to both sides. Yeah, both sides. Now, again, the rule that we have seen just before. So x can be written in front of ln. 1.2 is equal ln of 6. So divide both sides by ln 1.2, ln 1.2. So it's going to cross out, it's going to give you 1. So therefore, x is equal to ln of 6 over ln of 1.2, which can be calculated and give you some approximation. So you can do that for me, and we can see if we do have the same answer.